Okay, so here's a polynomial in factored form. Okay, thank you for pointing that out. I have a square up here and thinking about the numbers, and that's real important. Okay. Right there, the zeros, they occur at x equals 4, -4, and 7. And I think everybody pretty much got this. Of course, your numbers are going to be a little different. But the 4 is everybody's going to have 0, 4, right? I think I saw that. I'm just about everybody's taken. Okay, so Y-intercept occurs when x equals 0. So y equals 0 minus 4 times 2 times 0 plus 8 times 0 minus 7 squared. And you can do the arithmetic. You're going to have negative 32 times 49. You're going to make me multiply that, aren't you? Okay. Well, 32 times 50, 30 times 50 is 1,500, right? And then 32 times 50 will be 1,600. And 32 times 49 will be 32 less than 1,600, which will be 1,568. And I think it'll be negative, because you got a negative here, that's going to be positive. So put a question mark on that. It might be right, it might be wrong, but you got your calculators. Okay. And maybe you're just really good at arithmetic and don't even need the calculator. Okay, so anyhow, there's our information. Also, as x goes to infinity, specifically as long as x is bigger than 7, then all of these are positive, right? As x plods along toward infinity, then y, which is a product of a bunch of big numbers, is really homogeneous. Okay? Because you actually multiply 4 big numbers together. You're really squaring one of them, that's the 2, and then this one and this one. That makes 4 big numbers. And every time you multiply a big number, the thing gets that much bigger. So y approaches infinity fast. I've spelled this out in more detail in previous classes. You might want to take a peek at those videos. You might want to look at explanation to see elsewhere, open math or any internet source. Okay. As long as it's consistent with what the text says and what I say, could be helpful. Okay. So as x goes to negative infinity, these two factors are negative. That's a badly written 7. Make it even worse. So what you have is two big negative factors, which give you a really big positive factor, right? Multiplied by one that's already positive and big. And y is positive. So y goes to positive infinity again, fast. Okay, let's just put a positive of this infinity here. Just indicates that we always want to think we're going to positive infinity, which means we're going up, or we're going to negative infinity, which means we're going down. Well, as soon as we've done all this, and this is what you should do automatically before you even sketch a graph. You put this information on your graph. Now, if you really want to sketch a graph first, find that helpful. But I don't think it's particularly helpful. I think you're distracting yourself with the graph when you need to be getting your information. But you might have a different way of thinking about it. So either way is okay. All right, so my zeros occur at -4, 4, and 7, right? Well, let's put a scale in this. Let's not get right a scale from -1,000 to 1,000, because then 4, -4, and 7 on the x-axis are going to be so close to the x-axis you can't tell them apart. Can't even see which side of the y-axis they're on because they're so small. So you don't want a big scale for your x, because once you get past these numbers in that direction or that direction, things happen really fast. And curves upward or downward really, really fast. Okay. So we put our information in here, but first we put a scale on it. And I'm going to put a scale where 8 is here. -8 is here, so now I can locate 4 and -4, and 2 and -2, and subdivide any other way I want to. Put my units down here if I want. And I can get my 6 here, and I can do units. I don't have to label them all, but of course I label as many as I need in order to locate my point. Well, -4 is obvious. I didn't even need to divide up this negative axis. So I'll use purple chalk to indicate my zeros. Here's an x0, -4, 0, +4, and 0, 7. I'm not even going to label those because you should know what they are, but when you do it, you need to label them, okay? Just to reinforce to yourself what it is you're doing. There's all kinds of things that go through your head if you're thinking about the labels that help you retain the information, making it more likely that you do well in the test and more likely that you'll succeed in future math courses. Okay, both of which are important. Okay, then we have a y-intercept at -1,568. Well, yeah, okay. Now here just a little further. We'll say that here we have -1,600. So that -1,568, I mean, we can subdivide. Here's 800, here's 1,000. Sorry, here's 800, here's 1,200, here's 1,400, here's 1,500. 1,568 is going to be really pretty close to -1,600, right? So there's our y-intercept again. Be complete, you ought to label 0, -1,568. I might label them, but I'm going to draw my graph first, and my labels don't get in the way. Okay, then, as x goes to infinity, y goes to infinity fast. So I can take the long run behavior. I just indicate that by an arrow here. It says this thing goes up real fast. And this side goes positive infinity. And if we go toward negative infinity, it does the same thing. Once we get past here, it turns up here really fast. Well, there's most of the information I need to graph this. I've got to come down through here and through this point. And up through here and down through this point, but that's not going to take me back up, is it? So it means that something is amiss with the idea that I should go through all these points. Well, I don't have to go through all the points. I can hit a zero by just like a parabola does its vertex, right? Or like an x cubed function, of course, that goes through the zero, right? Okay, so just looking at the fact that you can have a parabolic approach, I could possibly come down through here and then back up, but ain't going to work. Okay, because that takes me through the y-axis before I get down into the negatives again, right? So I can't do this because I can't get through zero between here and here. The only place I get through zero is at these purple marks. Those are the only numbers that give me zero here. Any other number, none of these are going to be zero. So when you multiply, you're not going to get zero. Okay, so I don't turn around here. But I could come down through here, I could turn around here, and then come back up, right? Or I could come down through here and up through here and then turn around here and go back up. Well, you can turn around down at either of these points and satisfy all the conditions of the long run behavior and the x and y intercepts, okay? Zeros to the y-intercept. Which one do I turn around at? Well, as I said last time, I think, I've got x minus 7 quantity squared. If x is close to 7, then what I have is just what I get here when I plug in 7. If I plug in 7, I get 3 times 22, I get 66. So when x is close to 7, these numbers are close to 66, so the graph is close to 66 times x minus 7 squared. Now you can remember a rule, or you can remember what I just told you. You'll understand it better if you remember what I just told you. So if you remember the rule, I'm still happy, okay? Whichever way gets you there. Tells me that this thing acts like a parabola here. It acts like a parabola 66 times x minus 7 squared. So there's when we turn around. So now we just come on down through here. We're going to come down a little lower. So we come back up through here. And we come down here and then back up. Okay. And then I'll just put a little note on what I said there in case you understand it. X like 66 times the quantity x minus 7 squared. And that's just vertically stretched x minus 7 squared, right? So if we vertically stretch the x squared 66 times, that makes it really narrow on an equal scale, okay? On this scale, not, well, pretty narrow on this scale too, but then x minus 7, you're replacing x by x minus 7. That's just the graph over. So you start with the graph of x squared, you vertically stretch it, and then you shift it over 7 units, and that's what you have here. So in this whole vicinity of x equals 7, it acts like this. Now, I might even ask for that on the test. Could be an extra credit question, okay? Give you a few extra points if you know that. So it's worth knowing, but don't neglect the things you really have to know. In order to do that. If you understand that, it's really good. And if you show me you really understand that, even if I don't ask, understand it and put it down on the test, I'm going to give you some credit. Okay? Because you are almost certain to have to graph something like this. Okay. Now, the stuff that's due on quadratic functions, that's not due until next week. It's not going to be in the exam. I like to have that on the midterm, but given the way the calendar is, I can't fairly put it on the midterm. Although I might put it on the midterm where it's optional. An optional problem counts if it helps your grade, and I just discard it if it doesn't. I'd recommend that you know what to do with quadratic functions by the time you get to the test. Okay? As much as possible. But don't neglect the stuff up to that point. All right. You will need to know transformations. And you will need to know the basic functions, including show me the arithmetic, show me the rules, and everything. Okay? And I'm probably going to ask you to graph them all. Maybe not. We'll see how long the test can go. Another thing on the test is there's no time limit. Okay? I design it for something that ought to take a couple of hours. I've had people saying they're all day. Although after the first couple of hours, I probably don't get anything much done. But if you work really slowly and deliberately, I have had people that just work slowly and deliberately and really do well. Okay? So you're not going to be under time pressure. Other than maybe the time pressure of your regular schedule. Okay. There it is. That's how you graph this. And that's things you need to think about. Okay. Now, some of the stuff about multiplicities of zeros and stuff hasn't come up until like the third section of the chapter. Okay. But this stuff about M behavior, zeros, and intercepts, you need to know that. And I actually don't remember if the first section asked you to be able to distinguish where you turn around. I think it does. If it doesn't, then if you happen to turn around at this point, I'm going to say, well, it doesn't really turn around there, but you're not responsible for that yet. So no problem. Okay. But if it's there in the materials, it's there in your homework, then you would be responsible for them. I'll be as fair as I can within the context of what you're responsible for. Okay? Okay, quadratic functions, the function the form y equals f of x was ax squared plus bx plus c. Of course, you know what the quadratic formula is, and you know that the quadratic formula tells you where the function is 0 and all that stuff, right? Okay. You have zeros here. You don't necessarily have zeros. Because, of course, you could get a negative under the square root, so you wouldn't have any real numbers that are 0. They give you 0, right? Okay. Now, everybody familiar with this, right? We've done this. We talked about the axis of symmetry in here. Okay. We've done it in the support class, and sometimes I have trouble remembering what I've done before, because we've kind of done it recently. Okay. So can you tell me? Okay. Okay, axis symmetry, the x equals negative b over 2m. For sure that I explained why that's so. Then, of course, the y-intercept. When x equals 0. So, what you end up with might look like this. That was wrong, but yeah. Opens upward with a vertex below the x-axis, which means if it opens upward and the vertex is below the x-axis, you've got 2 zeros. Okay? That means that b squared minus 4ac has to be a real number. Okay? So this is if a is positive and well, could say the square root of b squared minus 4ac is a real number. But that comes down to b squared minus 4ac is greater than 0. Okay, let me ask you this. Now, what if a is negative and b squared minus 4ac is less than 0, meaning it's negative. And let me just draw, you draw your axis symmetry anywhere you like. I'll draw one here if you have to decide where to put it, okay? Sketch me a graph that satisfies that. Okay. If b squared minus 4ac is less than 0, then you don't have any zeros. You can't go through the x-axis. So we have to know that this gives us no zeros. Because this is negative and you can't take its square root. You can, but it's not a real number. Also, y goes to negative infinity as x goes to infinity. Y goes to negative infinity as x goes to negative infinity. So it's got to go down. So it's got to have a vertex on the axis of symmetry. And it's got to go downward on this side, downward on this side. It can't go through 0, it's got to go down on both sides. Why does it have to go down? If x is a big negative number, then no matter what a and b are, ax squared, if x is big enough, ax squared is going to overpower bx. Plenty of explanation of that. Okay. So I could put conditions on that, but x squared just grows way faster than x does. Well, if x is a really big number, whether positive or negative, x squared is going to give you something that beats this, but x squared is going to be positive, right? No matter whether x is a big positive or negative number, when you square a number, you get a positive. That means that this thing's going to go down. Y is going to have to be negative when x is really big, which means that a is going to be negative. So the graph has to reflect this. If you put it up here and curve it downward, you got two zeros and it can't be. There's a discriminant. If you put it here and upward, it wouldn't have zeros. If the vertex is here, it wouldn't have zeros, but it wouldn't have the right long run behavior. Okay, that's what you have. Another two other cases. If A is positive and the discriminant is less than zero, then it is like I just described here. It's going to be above the x-axis. It's got to open up. But if you look at the long run behavior and the discriminant to see whether you have zeros or not, you can conclude what the graph looks like. The other cases, well, there are actually a few cases. You got a case that would look like this. A case that would look like this. And I'm not drawing these very well. And also you have cases where the thing it's the x-axis when x is zero. Okay. All these possible cases. Vertex form is this. X equals H is your axis of symmetry. You can expand it, put in the general form ax squared plus bx plus c. Okay. And also I should have set it up here. HK is your vertex. A is the same in both cases. Exactly how this is useful. Find the vertex of this thing. Start by finding the axis of symmetry. I'm not sure what your statement is saying, but you have the right axis of symmetry. What's AOS mean? Oh, axis of symmetry. Yeah. And you want to say that as x equals -2. So you know it's a vertex form, although that's a little bit slow. So okay. Okay, so once you find the axis of symmetry, so you've already gone on to find the vertex. So now what do you know about A, X, and H? In other words, you can put this into the vertex form. If you got the vertex, and understand what I told you, you can immediately write down the vertex form. You really ought to have the question, but you have reference to it. Okay, well, what you do, let's figure out. Okay. It's negative. So unless you get that, it's not going to work out. You got it. You just missed the negative something. Okay, that much is almost either you got to find the both coordinates of the vertex. The vertex is going to be on the axis of symmetry. So hopefully take that information. So that looks good. Okay, just let's give everybody a chance to get it all done. And actually, still recording. But that's not a problem. Okay. So, find the vertex of this. It's an x equals negative b over 2a. Let's work that right now. Try to make it better. Okay. So b is 8, right? That's negative 8. I think everybody got that. Over 2 times a, which is 2 times 2, which is negative 4. Now at this point, you can start doing this stuff. Just keep yourself on track. I said before with the polynomial, get your intercepts, get your long-term behavior, long-run behavior, because there really isn't anything you can do until you have all that. In this case, the parabola, so you know what the shape is going to be. So the first go ahead and say, okay, and it's negative 2, not negative 4. Okay, so let's go put negative 4 here. Negative 2 will go here. 4 can go here. 2 can go here. We're not going to need those. That might as well have. Okay, so now we know that the axis of symmetry is here. We know the vertex is on the axis of symmetry. So the vertex I use the f of x notation if you're going to see it. It's an f of -2. So if this is y equals f of x equals 2x squared, I can talk about f of -2. And this, all this is saying, telling you is you're going to plug -2 into this function. Because x is -2 on the axis of symmetry, and you want to point on this graph. So that's -2 times, 2 times -2 squared plus 8 times -2 plus 6. Well, that's going to be 8. That's going to make it 14. That's going to make it -16. So that's going to be -2. So coincidentally, I can plan it that way, but your y coordinate of the vertex is the same as your x coordinate. It's at -2, -2. So your y-intercept is very clearly at y equals 6, right? Okay, so the y-intercept I assume you know how that comes about. So if that's 6, then -6 here, -2 would be about here. So that's 4 there. 2. That's more or less right. So now the vertex on the axis of symmetry of y equals -2 passes through the y-intercept. On this side, the graph is going to look like something like this. And on this side, it's going to look very similar. Make it as symmetric as I can. Okay. So there's a picture of the graph, but there's one more thing you can find, which is the zeros, right? X would be -8 plus or minus the square root of 8 squared minus 4 times 2 times 6 over 2 times 2. And that's very straightforward. Just doing well with quadratic formula. I don't think anybody has any problem with that. This is going to be -2 plus or minus square. Well, that's 64. That's 48. That's -2 plus or minus the square root of 16 over 4. And you see, here we have zeros at -3 and -1. Meaning, when I did this, I didn't do that great a job, but then I probably didn't scale the graph all that well either. I think my -2 is a little too low here. Vertex should have been up here, and that might have taken me through 0, 1. Or -1, 0. Sorry. Okay, but these aren't quite right because of the scaling of my graph. You know, this is too close to 0. This is too close to 4. They should go through here and here. It's reasonably close, given that it's a hand-drawn, hand-scaled graph. Okay, now the vertex form, which is what we're really after here. Well, A equals 2 because A is the same here as it is here. h equals -2 because h, k is your vertex, right? So here's your vertex form. Y minus -2 equals 2 times x minus -2 quantity squared, or y plus 2 equals 2 times the quantity x plus 2 squared. Now I can square that and then add 2 to both sides. If I expand it that way, it's going to give me this. Okay. By square x plus 2, I get x squared plus 4x plus 4. If I multiply that by 2, I get 2x squared, which matches this, plus 8x, which matches this, plus 8, which doesn't match this, but then I have to subtract 2 from both sides, and that gives me 6. So it does match. So we've come full circle. I don't have room to write that last step down, so you don't want to make a comment. Check it out yourself. Okay. Now there are some word problems you're probably going to find a bit challenging. Also, I'm not sure that the camera is over far enough to see all that, so let's make sure that it's all visible. So if you're looking at the video, that should be an improvement. Okay. Now there's a question about a problem that I'm not going to attempt to do. And I won't put problems like that on the test. You can expect them on the next, because I'll talk about them later, okay? But one problem that you can expect to see is I'm going to use T instead of that. The maximum height when does it occur? Well, the graph of this thing is going to be a parabola, and you can graph it. The axis of symmetry, so you're going to have t instead of x, you're going to have y. T, not x. Axis of symmetry is going to occur t equals 2. In other words, you can graph this thing. Okay? Your axis of symmetry is at t equals 2. Your y-intercept is 10. Your vertex occurs when t equals 2. Y is this, and that equals what? Well, that's 4, that's negative 20, that's 80, 90, that is 70. Y is 0, C is negative 40, plus or minus the square root of 40 squared. And then minus 4 times 5, negative 5, which is 20 times 10. Plus 200 over 2 times negative 5. Simplifying that, that's that t equals 4. T equals, I doubled this in too many times. This should be t equals 4. I should have a 4 here and a 4 here, which gives me negative 80 and 170, which is 90, not 70. And I think that's right. That's how you calculate. Now, I'm just doing the same thing I did over here. To find the zeros, and this is a 4. That's a square root of 600, which is about 24.5 over m. Approximately 4 plus or minus 2.4, which is 6.4 or 1.6. So this is 4. Here's 2, here's 1, here's 3, here's 6, here's 5, here's 7. 6.4 would be about here. 1.6 would be about here. It's not right because this thing is upside down, so why would it wrong? If I have 10 here, I have 90 up here, I have the graph here. With my zeros. Something wrong. But the whole point is, this is how high it goes. Maximum height occurs at the vertex. If you get the vertex correct, according to my calculations, and you can correct them, the vertex, I think, is at 490. Question mark, because some things about the graph don't appear to reconcile, like the zeros don't seem to be consistent with where the vertex is and the Y-intercept, okay? Oh, no, well, okay. No, yeah. Okay. 40 squared, 1600, that's 1800. So that would be like 40 over 10. That's about like 4.3. And that works out, that's like 8.3 or negative 0.3. So that might be 8.3, that might be negative 3, it might be a little steeper. Again, what you take away from this is, if you do the graph, Y is how high it is, and that's as high as it gets. So the Y coordinate there is 90, so that's how high it gets. And when does it happen? At t equals 4, that's maybe after 4 seconds, right? I don't know who threw that ball. Pretty good throw. Okay. I don't know if it's feasible. We probably hit one that well. I don't know if you can throw it. Okay. Good deal.